How come my download on that Thanksgiving thing only had the vectors in it?
Well, did you get the text I sent back to you, the email I sent back to you, show you where to look for the toolpaths?
I got it, but I couldn't find any.
Then I would
What I
say,
downloaded was exactly like the ones that you sent me
okay,
with just the vectors in it. So
interesting. Did anybody else download the file from last week?
mm,
I tell you what, go out to the website, the Next
Yep,
Wave
I did.
website.
I
Okay.
downloaded it.
Did you, Willie?
Yep.
Did it have the toolpaths in it?
Yep. In fact, I was going to ask you, you got it set up as like 200 miles an hour or 200 minutes a second or whatever. I don't think I've ever ran anything at 200.
So,
you gotta change them.
well, it depends on which machine or which spindle you're doing, but I ran that with a 2-horse spindle on the HD 500.
Okay. And then no problem.
I didn't have any problem.
Okay. Because I got the 510. So,
Yeah, now if you're now again, I as the introduction of that says where it pops up, if you're not comfortable with, you certainly could go change them.
yeah.
Part of what happens with the CNCs and Next Wave's machine does this as well, is that 200 inches a minute is a straightaway speed. And I compare it to kind of like if you got your car could go, let's say your car could go 200 miles an hour, but you're not going to do that in a neighborhood or around a curve. And so all CNCs have built-in governors, so to speak. When they hit a curve, they slow down. And so even though it's set at maximum speed of 200, it's not traveling that fast when it goes around the shapes.
Okay.
Where you do find a difference where the higher speeds will be a problem is if you're doing really small areas like little lettering or cutting little holes or little details. Then it tends to act like a sewing machine. It gets real jittery, and then that's a good time to slow it down. But yeah, I just edited a file for a guy today who was cutting. Basically, they look like coasters with a cutout for like the glass to go in. And he had his speeds. He was running actually, he was running the HD 544, that big tool that Next Wave made. But he must not have checked the feed rate because he had it set at 40 inches a minute, and that's super slow.
Yeah.
So, and then he had the plunge rate at 10 inches a minute, which is also super slow. It's like going down like a snail. So, on Next Wave's basic machines, the let's see, the maximum feed rate on their basic HD machines is 200 and the plunge rate is 100. So even if you set it faster than that, it's not going to move any faster because that's what the governor limits it at. And then, like I said, within the controller, there's even a secondary governor, which when it starts to go around a curve, it slows down quite a bit even further. So that's how you can get by with setting it at almost, in that case, I set it at maximum speed and it cut just fine.
You know what I'm running, don't you, Randy?
What are you running?
I got the one of the original Pro Plus. Got a
Oh, okay.
blue bed on it's 25 by 25.
Oh, yeah.
I only run a one horse little one horse router on it, and I've never had any problem. I don't run up max. I run about 100,
Yeah, that would make sense for that machine.
and I generally run if I'm in oak or walnut 70 or 80.
Yeah. And then how deep a cut are you taking?
I generally take half the width of my bit. If I go
So
quarter inch bit, I generally take an eighth of an inch.
that's pretty good. That's pretty good. Yeah, what I recommend is that if people are having issues with the machine, either leaving, let's say, chatter or rough surface, take a shallower cut, but keep the feed rate up because that gives you a better chip load. but it puts
Yeah.
less stress on the router bit and just the whole gantry. Those older
Well,
machines were a little more flexible, so they're not quite as capable as the newer machines.
when I start off, when I start off, that's the first thing I'm looking at is the chips that are coming out of there. If I got sawdust coming out, then I slow it down a little bit.
Right. Well, you can see the picture on your screen right now. Those are the chips that are coming off of that V bit, and you can see they're little tiny chips. They're not sawdust, so that's really what you're looking for.
Yeah.
It's not always possible because there's some types of bits and some types of cutting where it's difficult to get that, but when you can get it, it's always better for everything. So, well, with that, welcome everybody, and we'll get rolling tonight. That's all right. That's I like the pre-meeting discussion.
Okay.
All right. Well, once again, we'll record tonight's meeting and I'll send out a copy of that to you when that gets posted. Just a reminder that next week, Thanksgiving week, there will be no webinar next Tuesday night. But starting in December, we've got a new project. It's some Christmas holiday ornaments. And much like we've been doing now, the first session will be dealing with the design aspect of taking some vectors and doing some special cleanup on them. And then on the 9th, we'll get together again and talk about some of the tool pathing for doing small objects like this. So that's what's coming up the first part of December.
How long are they planning on running these?
Oh, so Next Wave has asked me to do a project every month. So I'll be doing a project for them every month. And then I'll be doing at least 2 webinars a month. One will be like the design aspect of the project, and the other will be the tool path. And of course, like we do every week, if people have special questions, we'll deal with those as well.
Is that into 26? How far into 26?
Well, right now they've asked me to do a project of the month every month in 26. So I expect I'll be doing at least 2 webinars a month coming up in 26 as well.
Oh, wow. Okay.
So, if you want to tune in or catch it afterwards, I'm trying to, each one is kind of a package deal in the sense that tonight we're going to be talking about the tool paths related to that Thanksgiving dish. And there's some special things to look at that, some tips and techniques we'll talk about there. As you all know, it's a long learning curve. There's a lot to learn. So there are classes out there like the one I have that you can certainly tune into for several hours worth of material and do that. I also kind of like the project approach. It's kind of practical, and I've gotten some really good feedback from some of you guys and other project tips you're working on. And oh, by the way, while I'm on that topic, along the way here, we're going to be doing some show and tell, some tips and techniques that you guys have. And one of them that I'd like to pursue, and Fred actually sent me some information on this, some hold down ideas. And I think I'm going to put together a package of kind of hold down tips and techniques. So if anybody has anything they'd like to send my way, a photograph of your favorite hold down or something you're using, or even just type it out, tell me what you're doing. But a photograph would be great, because I'll put together a little show and tell then on those topics at some point coming up here, and that'll be one of the topics we talk about also. So with that, I think we'll get rolling into the topic tonight. So tonight we're going to be talking about the tool paths related to this month's project, which is the Thanksgiving dish project. And in particular, I'm going to be talking about the toolpath setup tonight relative to this. Also, how V carving differs from chamfer toolpath. We're using both of those in this project. And in one application, the V carving toolpath is the preferred method. The other one is the chamfer. And then I've got a couple of toolpath savings options. And again, this is all covered in the project of the month handout, which is available on the Next Wave website. So all the step-by-step, it's written kind of like a magazine article. All this is covered in there as well if you want to see all the photos in even more detail for clarity. But in particular, this is the finished project. It's a 2-sided project like we talked about last week. It's got the dish side and obviously the bottom side of it with a little lip on it, some V carving. On the top side, we have three primary tool paths we're looking at. We're looking at the V-carve pocket, which is being used to carve out the center dish area. And then we have the V-carve text down at the bottom of that, which we carved out at the bottom of the bowl. And then the registration holes that we use for registering it when we flip it over. And then on the back side, there are three main tool paths we're looking at. One is the chamfer, and this is where we're using the chamfer tool path rather than the V-carve tool path. And then we have a little lip that we're going to machine around the edge, and then of course the cutout with the tabs will be part of that as well. And with that, let's go ahead and hop into the V-carve demo. Okay. Now, this is where we left off last week. We had drawn all the vectors based on these dimensions that I had shown you. And so then tonight we're going to be looking at these tool paths that I've set up on the right side over here. And based on this picture we just saw earlier, we've got a dish cut in the middle that we're using the V-carve tool path for. And of course, there's a clearance path that's set up, which is going to be a larger bit to clear that out. And then we'll go back with the V bit to do the beveled edge. And then we do the text and design work in the bottom of the dish and then cut the registration holes. So it's essentially three tool paths, but you can see over here I have more than just three set up, and I'll go into the details of that in a bit. For this tonight, for this project, the three main tool bits that, router bits that I've been using are a 1/4 inch end mill. And end mill again refers to the fact that it actually has cutting edges on the tip of it. But then for hogging out or clearing the large center area, I used a 1/2 inch straight bit, although an end mill would also work. What you see in the picture here is a straight bit, and you can see there's no real blade, especially in the middle here. There's no cutting. So it does not work as a drill bit. That's the main difference between a straight bit or a standard straight bit and a end mill type bit. And then the other bit is a 60-degree bit. This is what you see here is just a standard 2-flute brazed carbide tip bit. However, I also have this, what you see on the right here, which is an Amana insert router bit, and it's a pretty amazing bit. Kind of pricey. I think I paid about $65 for it, and the inserts are not as cheap as the other ones, but it has a super sharp edge, and as you can see, it has a super sharp tip to it. It's also a single flute as opposed to the 2-flute, and as we've talked in the past, the single flute actually doubles your chip load. So for the same RPMs, you get twice as thick a chip, so it's easier to get nice chips off of it. And it is available at a 1/4 inch shank, which is what you see here in the picture right here. And the brand, the number is right on it. It's an RC 1148. You can find that out at the Amana website or one of their distributors. There's also some generic versions, or I guess you'd say Chinese-made versions of these available too. You might save a few dollars on that. I've not had a chance to try those to see what the quality is, but it appears as though Amana probably lost their patent on this bit, and that's why those other bits are on the market. You might find something on Amazon like that. But I had a real good experience with this bit overall. I really like it. And for larger sign cutting, it's about an inch and a 1/16 in diameter and has a cutting depth a little over an inch. So it's a very generous bit for doing larger cuts, and something like this dish, it's a perfect match for that. And so this kind of shows the setup on the machine, just finishing up. You can see here that we've got some pins in here for registration. The main area has been machined out, and we talked a bit about the registration pins last week. For my setups, what I use for registration pins, let's see if I've got a picture. Here we go. I use this PEX. It's 3/8 inch diameter PEX plumbing pipe, used like a supply line. I just cut sections off the utility knife and they work really well. They're consistent diameter, and obviously because they're plastic, I don't have to worry about running into it with my router bit, and it's really inexpensive also, and mostly the consistent size is what I like. And again, once the whole top side is done, that's what it's going to look like. I did a bit of sanding to ease that sharp edge around it, to give a little bit of a rounded lip, and then sprayed some lacquer on it. So with that, let's take a look at the vectors. For this setup, when we did the original drawing, we drew this outer vector. That's the outside lip of the shape. We actually don't use that on the top side, and we copied that over to the bottom side, but that's the overall dimension of the dish. But it's this inside vector that we're actually going to use when we do the V-carve pocket. And so for that, if I open this V-carve, that's the standard V-carve toolpath. And using the dimensions off of our drawing up above, we're using a 1-inch thick material, and we're cutting 3/4 of an inch deep. Now, the settings that I chose for my setup on this, if we look at these, is I'm doing a fairly shallow pass depth, about a 1/16 of an inch. My final pass step over is 2%. That gives me a nice clean finish around the edge. But then I'm using a clearance pass of 40, which is a little bit more aggressive than you might do with like a 45-degree bit. And I found it worked out well. It saved a good bit of time. The spindle I used, the 2-horse spindle, I had that set at 22,000 RPMs. And again, I maxed out the feed rate and plunge rate, and I didn't have any problem on my HD 500 tool with the 2-horse spindle. It worked just fine. Part of that is because I'm not cutting super deep, but it keeps the router bit moving and gives me a nice chip load on that. And then for the clearance bit, I'm using a 1/2-inch, it's called an end mill, but it really was just that straight bit. I use that term interchangeably because when I go to my machine, I know which bit I'm using. On this one, again, I did a fairly shallow pass depth. Now that's partly for those people who have lighter duty tools or older tools. If you have a 510 or a 520, you may find that you can increase this to, depending on your material, you could potentially increase this to even 1/8 of an inch. But again, that'll be based on your experience with it. The tool that I had, I seemed like this was actually a good fit. Plus, I'm using a 1/2-inch bit with a 40% step over. So it's, it's taking off a good bit of material as it's cutting it. Now, for the tool-specific options here, I chose a raster, which is going to go left and right in my setup here. And I like to go with the grain because when I get down to the bottom of this dish, it leaves the smoothest surface. If you go cross grain, you do get some cross grain scratches, and they can be much harder to sand out. So if you decide to change the direction or need to, you could go into this raster angle, and if I type 90 in here, it'll go the other direction. It'll go vertical. It's always a good idea, whether you're using an end mill or a straight bit, to add some ramp. And I usually add about 4 times the diameter of the router bit, depending on a little bit which tool I'm working on. But for this one, I added 2 inches, which worked out well. And then for the vector, I'm selecting that main inside vector there. So we'll calculate that out. Let's reset that. So again, I have the clearance path, which is going to take that inside out. And it's acting just like any standard V-bit, V-carving bit. You're getting little steps in here based on your pass depth. And then it's leaving a little extra for the V-carving portion of it. Now, the V-carving bit is going to come back in, and I don't know if anybody has experienced this or not, but you're going to find that you see how I've got 2 ovals here. The V-carving toolpath, it seems a little different than what I've experienced in the past. And this middle one is actually, for the most part, it's just cutting air. And they've added that in there because some people prefer to cut their V part of it first, which is totally acceptable. And sometimes it's actually preferable. And we talked a little bit about that last time. And so if you want to cut your V bit first, there you can see how it's cutting, and that's what's left from that. And then the straight bit goes in and cuts the remainder of it down like that and cleans it right up to the edge. So with that, then we have the inside complete. And so with the one tool path, we then are able to get both of those set, or the clearance and the V carving. Now the text in the turkey part of it, that of course is the middle part, and we can see here again, that's highlighted in blue. If you haven't discovered this, this checkbox right here makes the tool path visible or hides it. So if I check that, you see the blue part. Now the blue is because I have this option up here checked. If I uncheck that, then I just get the little lines that show me which direction the bit's carving and where it's carving. You can actually see how it goes up into the corners. That's actually the middle or the tip of the router bit carving around. So it's carving down the center and up into those corners. But if you want to see where the whole bit is cutting, clicking on that, solid preview gives you that blue highlight, and it's quite handy. And we're going to be taking a look at that, especially when we get to the registration holes. Now, one of the things to think about when you're setting up for this tool path, because we're carving down in the bottom of this dish, we need to make sure that the carving carves on the floor or the bottom of that dish shape. So notice in the V-carve toolpath in the upper right up here, I've got the start depth set at 3/4 of an inch. So the bit is actually going to drop down to that, and in a minute, that's where it's going to start carving. So if we'll calculate that out, select the vectors. So we tip it on the side, you can actually see how it's dropping down those light green or blue lines all the way to the bottom. So it's pretty handy when you're carving inside a pocket or a low area, and that's how you accomplish that. Preview that. Looks good. Now, the last thing we need to set up on this side are the registration holes. Now, as I mentioned, I'm using 3/8 inch material or, doweling for this. So these holes, I've got this one selected. And if you look down the right, you can see the W and the H here. That shows it's 3/8 by 3/8 of an inch. And they're both the same. So I set my dowel holes up, or the registration holes, pretty much exactly what the material is. But as we all know, you have to allow a little tolerance for that to fit in. Can be that your bit might be a little undersized. If it's real hard material, that might make it a little bit smaller, and you just need a little bit of room for that pin to fit in. So here's what I'm doing over here. You can see I've got 4 different tool paths set up. What I do is I select my holes, and for this I'm using a 1/4 inch upcut end mill. We looked at that earlier. I'm cutting a little over a 1/2 inch deep because my pins are 1 inch long, and that by cutting a little over a 1/2 inch, it makes sure that I have enough space top and bottom for them to fit in, because I'll also drill these holes or route these holes into my spoil board as well. But I'm going to cut to the inside, And this is an allowance offset. We've talked a little bit about that before, but I'm going to show you how it's used in this application. So I've created that allowance offset of just 0 because we're going to cut exactly where it goes. In fact, if I zoom in, you can see how it's cutting right to the line. Now notice that if I turned on this next one, notice how it's a little bit bigger. And if I add the next one, it gets a little bigger and a little bigger. So the way I do that is, I'm going to set up an empty group here. Move that to the bottom. Let's do this. Move that up there. I'm going to take this toolpath and duplicate it and move it into that new group. So this toolpath, which says it's 3/8 of an inch exact. Turn these off. So I'll create one basic toolpath like this, and then I will duplicate it 3 or 4 times. So I have this basic toolpath set up for this one registration hole or these 2 registration holes. I'll then hit the duplicate toolpath icon right here once, twice, and again. Then this first one I know is set up for exactly where I want it for these 2 holes, for that hole and that hole. And then I give it the name 375. And again, it has 0 allowance. So it's going to cut that hole exactly to that size. Then the next duplicate copy, I open that up. Select those dowel holes again. In this case, I want this one to be, let's look how much bigger I'm making it. I'm making it 5 thousandths bigger, okay? So to make it that much larger, that ends up being 0.025 because it's adding that much to each side of the hole. Now, something we have to think about is that when we do an allowance offset on the inside, if we use a positive number here, it's going to actually move the toolpath to the inside because we're already on the inside. We want to move it to the outside, so we actually have to make this a negative. And so then what I type in down below here is actually my finish dimension, or my actual diameter is what I'm typing it down below. And then I hit calculate. Let's get those vectors selected. And then I open up the next one, select the vectors. And now this one's going to be, if we look at where we're at, we want this one to be 8.5. So in that case, we're going to set that up at that much allowance, negative, because again, that's adding that much to each side of the hole. Retype in the name, calculate it out, and then the final one, we're going to go 3.9. And so for that, we're going to go, let's see, 3.9, type that in down here. .75, so we're going to go 0.75. So we've added, 15, 0.0075 to each side of that, which doubling that will give us that number below and it adds to it. So that's how I create a range. Now, the reason I'm creating a range is that I want to save these all out individually until you get used to how your tool is cutting, the material you're working with, your doweling for your registration pins, whatever. Until you get that standardized, I find this really handy. So I use this often, but that way I can save all those to my thumb drive or my computer, and I don't have to go back inside VCarve and change it up to try it again. It just saves me a lot of time at the machine. And it gives me a range. I cut the first one, I test my fit. I cut the second one, I test my fit until I get one that fits the way I want it to fit. And then I remember that. And then the next time I use that pin and that same router bit as a pair, I'm going to be really close, if not exactly where I need to be. So that does it then for the top. So again, like I said, if we zoom in here, there's our basic hole. Gets larger, larger, and larger. And it looks like I have a couple of stray holes over here for some reason. So before we jump over to the bottom side, any questions on this top side for setting up these tool paths? Anybody feel like they would do something different? Okay, then we'll go ahead and hop over to the back side or the bottom. And the bottom, it's going to be very similar to the top side where it relative to the registration holes. But here's what's different on this side, is that these registration holes are not going to be cut in the material or the project board. These two registration holes actually get cut in the table or your spoil board because we're flipping our project over from the other side where we saw we had these two pins here. This board is going to flip over and those two pins are going to go into the spoil board. So when I set these up, pretty much the same thing as what I had on the other side. In fact, let me show you a little trick here. To go back to the top side, let me rename this. I'm just going to call that demo group. And right now, I've already have Toolpath set up on this bottom side for the registration holes. But having set those up in this top side, I can right click and do copy. And look at that. I can copy it to the other side. Now when I go to the other side, notice there's my demo group of all my registration holes. So you don't have to re-enter those all again. Now they have a red icon next to it because they are not currently associated with any vectors. So that's a really nice notice. That's like, okay, I've got the toolpath. All the information is the same. If I open one of these up, you can see there's my allowance, my router bit, everything about it is identical, but it has not yet been associated with a vector. So I would need to go in and open each of these up, select my two circles for my registration holes, and then associate those. But that saves you a lot of time when you're doing this kind of setup, going back and forth between the two sides. I already have them set up here, so we're good to go as far as that goes. Now, the next thing we're looking at, having set up the registration holes, much like we did before, I'm now going to turn my attention towards the chamfer on the edge. And for this case, rather than using the VCarve toolpath, I've set up the chamfering tool path. If we open it up here, now, if you haven't used this, or if you haven't, you're exploring it, you've got this inside outside slope down, slope upward. It takes a little while to get your head around that and understand it, but just play around with it a little bit, do the simulations and see what the results look like. But here's a couple of things to think about first. In the drawing on the right side over here, you see the pink line. That represents your selected vector, okay? And then inside, of course, means that you're going to place your chamfer on the inside of that line. And as you can see, that line that we've got highlighted represents just the bottom, right where the tip of that arrow is. And, and then notice how it says it slopes upward. So it's going to go from that line and it's going to go upward. Now, what gets a little bit confusing is that this arrow right here points down, which you can see compared to the illustration below. That's correct. But if you start playing around with this, and now it says slope downward, well, the arrow still points down because we've moved the chamfer the other direction. This would cause a big hole in the bottom of your bowl, and I will show you an example of that a little bit later. But again, now notice how your vector is moved to the top edge as opposed to the bottom edge. So give some thought to that. And then outside, it's going to put the chamfer on the outside of that line, again, either sloping up or sloping down. So again, there's quite a bit to keep track of there, but play around with a little bit, watch the illustrations, watch the preview, and make sure the preview looks what you want it to look like. Now, for our bit, as you can see, I've selected the 60-degree V bit up here in the upper right. The width of that dimension, that odd width right there, that 0.4041, that's partially calculated by this depth. And the depth of 0.7, if I change this to 0.75, notice how that width changes because it's calculated. Now the 0.7 is the one that I know, and the reason I know that the cutting depth is 0.7 from the top, from the bottom of this to that lip, is because if we go back and we look at the drawing on the first page over here, our lip is 0.3 thick. Our overall dish is 1 inch, which means from the bottom of the lip to the bottom of the dish or the material is 0.7. So that's how I determined for my chamfer setup that I wanted to have a cutting depth of 0.7. Pretty easy math once you understand where it comes from. Now, in this case, I'm not doing any overcut, okay? Because if I did an overcut, it would create a groove right at around that edge of that lip. The purpose of an overcut, let's look at it, do a quick drawing here, close out of that for a minute. Set up a little square here. So let's say that was your router bit and we were chamfering the outside edge. And obviously if we put the tip right on the edge, we get a nice chamfer going right down along that edge. In reality though, sometimes if your material or your router bit or your cut is off just a little bit, what can happen is that tip can end up kind of exaggerated here, but it could end up cutting and leaving a little teeny fingernail right there. And you obviously possibly can sand it off, but an overcut, if we look at it in the chamfering, the overcut, what that does is that moves that bit down this direction. So you still have the exact angle you want, but it overcuts it in the depth here, but it passes that tip beyond that edge and it generally leaves a cleaner edge. But again, for this project, we don't want to use this overcut because that would overcut and it would actually cut too deep. So in this case, we're not going to use it. But if you are chamfering around a project where you don't have a lip like this, then adding a little overcut is a good idea. So once again, let me just double check here, make sure I've got this set up correct. For the inside of that vector, we're sloping upward from that vector to the bottom. That looks good. So we'll calculate that. And there if we look at a side view, you can see how that is cutting that shape. Go ahead and preview this while we have it here. So that, again, it looks much like just a V carving, but the bottom of the dish is right there in the edge. So next up, we're going to cut the lip and then the cutout. And so for the lip, we're using that same vector that we used for the chamfer, but we're going to cut to the outside of it. And again, in this case, notice up here that I've got a start depth and a cutting depth on this. Those two together equal 0.7. Now, the reason I did this, and this is the file that I sent out with the project of the month, because it's, people just download the Toolpath and they cut it, is because if we look at this 3D view, it ends up cutting a lot of air before it starts cutting that lip. So I actually said drop down to 0.3125 before you start cutting. And that just saves some time on the overall cutting. And you'll find that if you can remove air cutting from some of your bits, you can save some time on the toolpathing. So again, we've got that set up. Let's go ahead and preview that. And there you can see it starting right there, and then it cuts the lip. Now, when I designed this project, I wanted to do this just in one single pass. In other words, I just wanted to have the width of the bit do all the cutting. So once again, if we go back to our top view here, you'll notice how the underside of that lip is less than 1/4 of an inch. That was just a small detail that I added in because I planned for that, because I wanted that 1/4 inch router bit to cut that in one pass, as opposed to using a pocket or a double pass or something. Just a little planning ahead for that. And then the last one we've got here is the cutout. And now the cutout obviously is going to go on the outside of that outer toolpath, because this is our overall diameter for our dish. So it's pretty obvious there. Again, here now we are cutting with the 1/4 inch end mill. I'm going a little bit more than a 1 inch deep because I want to make sure I'm cutting all the way through the material like that. I also have added, you can see a little tab right there. So the tabs that I'm adding are 3D tabs, and they act a little bit more like a speed bump. If you use the standard tab, the router tends to come to a stop, go up, go over, and come down again. So I like to use 3D tabs when possible. Again, I've added a little bit of ramp to it. And it's telling me I'm going to cut through. That's okay. Double check to see if I've got the right router. Let me double check on this. There we go. Okay, so what happened there was it looks like when I was editing this file, I had a different vector set up. So I'm going to go back in because it gave me a warning that there were no tabs. So I'll go back in. I'm going to do an automatic 4 tabs, see where it adds them. And that looks good. Say okay on that and calculate it again. And let's go ahead and preview that. So that's going to do the cutout around the edge. And leave me some nice tabs. Now, while we're on the bottom, if you wanted to add some text to the bottom of this, you could also do that. You could add the date on there, November 2025 or something like that. And you could add a little bit of, go in with the V carving again. We use the same V bit we used before. And you could certainly not what we want to happen. And what happened is that it defaulted to the start depth that I had into the last time. So that's actually kind of an important thing to remember, that the last settings you use for a bit will often pop back up the next time you use that bit. So this set that remembered that I was starting there at 3/4 of an inch deep, but I certainly don't want that. So recalculate it, reset it, and let's preview all visible. And there we are. Okay, next up, we're going to take a look at saving these. But before we go there, any questions so far on these toolpaths?
Randy, I got one on your. Now, you're using a Next Wave CNC, you are not.
I am using a Next Wave CNC for this, yes.
Okay, they take 5 data points. Every time, if I change bits, I've got to take 5 data points. If you flip back over on the other side, how do you get 5 out of that?
Are you talking about using the virtual zero?
Yes.
Well,
Well,
so
if
for those,
you,
go ahead.
okay, if you took 5 data points when you started, you got the 4 corners in the middle. Okay, you cut the middle out and you want to carve the Happy Thanksgiving, but you changed bits. How do you get that 5th point?
So 2 things on that. Virtual zero, you have the standard, like the small pendant, right, that you're using.
I don't use a pen, and I do mine with the computer, but it's
So
the
you
same
use the
thing.
ready to control?
Yes.
Okay. So I know that independent, and I'm 90% sure ready to control as well. If anybody else out there uses ready to control using the virtual zero app. So then you have the virtual zero unlimited application then with ready to control.
Yes.
Okay. Once you do your 5-point virtual zero scan of the top surface of this material, those 5 points are memorized by virtual zero, and you can use those for all your toolpaths. You don't have to rescan those 5 points.
Even when you switch bits.
Yeah,
just got
exactly. All you
all
have
you
to do
got-
is re-zero the bit. And again, I know how it works in the small pendant. I'm not sure about ready to control, but in the small pendant, it then asks you, do you want to reuse your data points or
Yes.
your virtual zero points? And you say yes. It then calibrates a bit. You still have to zero out your bit with the Z0 for every time you change a bit.
But it
then
doesn't matter where you do it at.
What's that?
It doesn't matter where you do it at then.
No, it really doesn't, because like, let's say you did it in this lower right corner, it's going to know that that's the lower right corner of your project.
Okay. And it'll,
And then it'll apply those five
okay. Okay.
points to that.
Thank you.
Yep. Okay, so let's talk a little bit about saving these. I'm going to clean things up here a little bit. I don't need this group, so I'm going to delete that. Now, what I want to show you on the saving side of things, you might say what I'm going to show you is an advanced technique, but once you see how it works and you practice it a couple times, I think you'll find that it really is a nice technique for certain projects where you have a lineup of toolpaths like this. So I'm going to go inside of Save here, and I'm going to select all these toolpaths. Now, if I do this first one that's called Selected Toolpath, that is only good. Notice how it's singular. There's no S at the end there. It's Selected Toolpath. This toolpath at the bottom, or say that first toolpath, whatever is highlighted in the grayed out in the bold, that is your selected toolpath. That's what selected means. So you can only have one selected toolpath at a time. So you can only save out one at a time using that option. The next option here, visible toolpaths, this refers to what's visible. And you can see everything here that's blue is visible. The check marks is what controls whether it's called visible or not. So if I uncheck this, I have no visible toolpaths. And if I click over here, notice how it says no visible toolpaths. If I check all of them, notice how I get an error message now that says the visible toolpaths use different tools and the post processor does not support tool changing. And we know that we've got a straight bit and a V bit, two different kinds of straight bits. So obviously it's a mixture. So we're not able to save those together using that. Now, if I just had those 4 registration holes, I'm saving all these together. I wouldn't do that because I definitely want to cut these separately. But notice that allows me to save all 4 of those together because they're all using the same tool. Notice in my case, the tool number is number 4, but it's also the 1/4 inch upcut. It's the same bit for all of those. So that second option up there is for when you have the same router bit, but you have multiple tool paths, and that works really well. But if you just want to save one tool path, then you just do the selected one. They could all be visible, but notice the only one that's going to show up here is the one that I have highlighted and, selected, as they call it. The third option is the one that I want to talk about tonight, which allows me to save all these tool paths in one setting or one setup. I'm going to get different tab files out of it, but it allows me to do this in one step within vCarve. So all those tool paths are all set up there. I've got them in the order that I want to cut them. And you do have an option here, group where possible. So if I clicked group where possible, it would group all these registration holes into one tab file. I don't want that because I want to cut them separately. But if these were 4 different shapes that I was cutting using the same router bit, that could be a good thing to do. You also could add the side to the toolpath. I'm not going to do that because I'm going to show you a little different way of doing it. This adds a preface, it adds the side, it adds the tool, it adds some extra information to the toolpath. I find it's a little bit redundant in the way I do it, but I'm going to show you this right now. So I've got all those toolpaths visible. They're all checked. They're all on the list up here. I have my machine, my post processor selected, and then click on save. And this brings up, and then you're going to find a place to put it. If it's going to be in your thumb drive or in your computer, just find a location to save the toolpaths. Now, in this case, it's going to use a file name, and it's going to be the default file name, the first one in the list. So you see it says dish vcarve clear. Well, that's not what I want to call my grouping. So I'm going to erase that, and I'm going to type in the word top. That's all I need to type in there. And when I click save, what's going to happen, it's going to put the word top in front of each of those toolpaths, and it's also going to automatically number them. So we'll click save. And bingo, I'm going to go back in just by hitting save. I can go back into that same folder. And there you notice there are all the toolpaths it created. Put the word top in the front, and it numbered them in the order that I want to cut them. So when you take this to your thumb drive and you append it, it becomes very convenient on how to save this. The only other thing that I might do, I'll go back. Let's see. The other thing you could also, like this says top, if you wanted to put like some abbreviation like TD for Thanksgiving dish, you could put that in front of it as well, so that this isn't confused with some other project that you have. That's another option. But in this case, for now, that's what we're going to save it as. That looks good. And that just saved all those toolpaths in one process step in VCarve. Now we'll flip it over, go to the other side. Now remember, on this side, let's see here. So we added that little text. I'm going to move that up right there. And I'm going to, well, actually, that won't matter. Let me just rename it anyway. I'm going to call that text on bottom. Actually, yeah, this is going to work out well. So we need to cut this, you save these in two separate steps. So we need to save the registration holes in one group because we're going to do those in the spoil board. So I'm going to make those visible. And again, I'm going to erase the default name there and I'm going to call it spoil board because that's where I want to be cutting these. And then I'm going to click save. And let's go back and take a look at those now. So there you can see we've got 4 spoil board toolpaths, 1, 2, 3, 4. And again, when I go to my machine and cut these, I'm going to cut the first one, check my pin, see how the registration pin fits. If it doesn't, I'll cut the next one, the next one, the next one until I find a good fit. So those just makes it very easy and available. Okay, next, we're going to save these last ones. Now notice we've got the chamfer, the text, and the lip. Now the lip and the cutout use the same bit, and the chamfer and the text use the same bit. So in this case, I can click group where possible. So it will actually group these two together and the last two together. So that's an application for grouping because it'll work for this one. Click on save. And on this one now, I'm simply going to call this bottom. But let me just do this. I'm going to put TD in here for Thanksgiving dish or turkey dish. Like I said, when I do projects, I'll often put the abbreviation of the project in it because that way it keeps this totally separate from everything else that I'm saving. And we'll see how this one saves out. Okay, go back in. And there you can see the example. So we've got a TD bottom chamfer, TD bottom text. Now, for some reason, it treated those separately. I'd have to go back and find out why. And then I've got TD bottom 3 and 4. It's calling it a lip cut, but we know that it's the lip and the cutout. So I'm not quite sure why it didn't group those two together. There may be some other setting that I missed, but you can see how it grouped the last two together. It named them 3 and 4. So I can then take this group of toolpaths to my pendant, starting with the top, click down through those, go to the spoil board, and then go to the bottom. And it makes it very convenient and very organized. The one thing you might want to think about too sometimes is you want to kind of control the length of your name. So registration hole, this might be a little long. If you have the small pendant, it may truncate it and drop off the number at the end. So if that's the case, you could just abbreviate registration, shorten that up if you wanted to. But it makes a very convenient way for doing that. Anybody else out there use that approach to saving toolpaths?
No. I have a question on spoil or on the pilot hole or the holes though.
Yeah.
You drill all the way through the project into the spoil board the first time? Or you drill the spoil board and then the project?
So on this project here, on this part, this is the top. I cut the top first and I drill. So my registration pins are about 1 inch long. And the holes that I drill in here are 0.6. So I'm not drilling all the way through this project. Now that's because
Okay.
this material is an inch thick. I don't need to drill all the way through it. Then when I flip over to the getting ready for the bottom, these registration holes, these get drilled into the spoil board. Not into, they don't get drilled into the project. That's why you don't see them here, because they're not drilled in right here. Does that help?
Somewhat.
Well, I tell you what,
Randy,
now- go ahead.
This key. I think the one thing that you're not mentioning on the registration holes is that they're flipping 180 degrees.
You are
And
correct.
I think that's where Bob's question is coming from. He's thinking you're drilling all the way through, but actually the holes are going to shift to opposite quadrants.
That is correct. So what? So Bob, if here's the, so notice here how the hole here is in the upper right corner.
That's
Notice
right.
when I flip it, it goes to the upper left corner. So it's a mirror image. And the reason it's flipping left and right is because of the job setup, we have it set up to flip left and right.
Right.
And
I
so
I don't understand how the holes are going to line up then, but okay.
Well,
I have to play with it.
Your registration holes on the spoil board are being done on the spoil board before you flip your project. And then once, so you're zeroing on your spoil board, and then once you've got those holes in, then you're aligning your part to the spoil board, and then you're zeroing on the bottom of your project.
that's correct, Gary.
Okay.
It is a little bit of a head spin until you get a chance to practice it. But like I said, download the PDF directions for this. I may have sent them out last time. I don't recall. And
You got 25 pages.
and practice a little bit. Now, like I said, I'm not drilling all the way or routing all the way through from my top side, but that's because my material is an inch thick. I don't need to go all the way through. On thinner material, like 3/4 inch material, you may cut all the way through. It's not a big deal. But the point that Gary was pointing out is that you have holes that are cut in the project board, and then you have holes that are cut in the spoil board. And those two line up.
Okay.
Anybody else, questions or comments?
Hey, Randy, back on the putting the figure in that in the bottom of the dish.
Yes,
Okay, when you were looking at the toolpaths, does that because you're using the top surface for is your zero and you're going down X amount? Is it coming? It looked to me like the toolpath, it was coming all the way back up every time it moved.
it does. Let's take a preview.
Okay.
Yeah.
And is there a way around not doing that, or is that just the world we live in?
So right there.
Yeah,
So
exactly.
yeah, it's lifting back up. I am not aware at this point of any way to avoid that.
What if you changed your zero to the bottom of the dish?
Yeah, that's just what I was going to say. That let's look at this another approach. You're right. You're right on. So if I go into this, and rather than doing a start depth, let's do a start depth of 0, calculate it. But notice now that it's actually cutting at the top of the material. But this is where you just have to, stay on top of what you're doing. Is you lay your for this toolpath, the text in Turkey, lay your zeroing plate in the bottom of your dish, zero right there, and it'll then treat that as the surface of your material, and you will save that extra up and down. Is that what you were thinking, Keith?
Correct. Yes,
Yeah.
exactly what I was thinking.
Very good. Yeah, that is a workaround. And I like that a lot because when you get used to some of these workarounds, you start to find that there's a lot of them with CNC that you can kind of quote unquote lie to your machine. You know, you tell your machine to do one thing and it's doing something different, but it's getting the job done. So that's great. Thank you.
And I think back on the registration holes, I think the one thing that wasn't mentioned, and I do this, but I don't think when you flipped it over, you have to understand that you take the part away and you drill the holes in the spoil board, and then you bring the part back and put it on top of the spoil board.
That's yes, very,
Yeah,
very good
I
point.
think the confusion was it looked like you were going to just flip the part over and put the holes in, but you put the holes in first and then flip the part over, or you
Right.
get the part out of the way.
You
and put the
remove,
holes.
yep. After you finish the top side, you take the material off your machine, route the holes in the spoil board, then flip it over and put it back down. You are correct.
Yeah, okay.
Now it makes sense.
Excellent. Made you smile, Bob.
Yeah.
All right.
Randy,
Yes, Brian.
how do you make sure that the text that you're putting on the top and the bottom, that they don't end up cutting completely through the bottom of your dish?
Ah, that's a great question. Okay, so let's go back to the top side. In this
electrical.
project, we have a 1/4 inch of material to deal with, okay? And obviously you don't want to cut through that. Now, two things to think about. First of all, the text at the bottom is something I just added tonight. It's not part of the regular project. So for now, let's just ignore the fact that I have text at the bottom. How do I know this isn't going to cut through? Well, first off,
That will give you depth.
let me do a test here. I'm going to go like that, set it up my conventional way where it's 0.75 and hit calculate. First off, it's telling me here that I'm going to cut through, but I'm going to say okay anyway. Let's preview this out here. Let's preview out these. Do out the dish, the V-carve, and then come back to the lettering. And obviously it cut through that little spot right there. Now, obviously we don't want that. I don't want that circle even. So I'm going to go back in and recalculate that. And notice I didn't get an error that time because it's not cutting through. Now, first of all, I didn't get an error telling me it was going to cut through. Secondly, if I go over to my Toolpath over here and I hold my cursor over it, see
You
that
use
little
that.
message box that pops up? It shows me a maximum depth of 0.8867. Do you see that on the right side?
Yep.
So my material is 1 inch thick. So that shows me that I'm not going to cut through the material because it's not going beyond that 1 inch. So obviously I want to have a little bit of material, and I've got almost 1/8 of an inch below my cutting. So that's one option. Again, if you're trying, sometimes, I mean, I go to great lengths if it's really particular. Now, here's another option. I go in here, let's just take that, do the 0 setting. Now, if I go over, again, it's just cutting on the surface. But if I go over to the right side now, so there's maximum depth cut, 0.1367. So that's actually how deep the V-carving is going. It's just going a little over 1/8 of an inch deep. So there's a couple ways you could determine that. Another risk that we have here is that we did add that carving to the bottom. And let's see how, so that's cutting 0.08. So that's cutting a little over 1/16 of an inch. So it looks like between that and the other one, we don't appear to be intersecting any place. But it's possible if you're doing carving at both sides like this, that it could intersect. And in fact, let's make a change here.
Curve on line.
I'm going to increase this. And let's see what happens now. Okay, so there, now we can see we got a little penetration. So that is something, again, make use of this preview window when you're doing two-sided work, or you're doing critical depth stuff. And, you know, really with anything, as I mentioned to people often, is that this preview is 99% accurate. What you see here is what you're going to get. So if something doesn't look right here, don't go to your machine, because what you see is what you're going to get on your machine. And in this case, we're going to get some little cuts going all the way through.
It would leak.
Yeah, it'll leak,
Thank you,
right?
Randy.
Other questions, comments?
Hey, Randy, I think also if you were to hover right in the very bottom of the V cut and look down in the lower right-hand corner, it shows you your Z depth.
It does. In fact, right now, if you
It's
look
showing you
at,
at 750.
yep, that's exactly right. That's how deep that is right there. It's a little trick here. I could actually go inside these letters, and you can see there it's 0.852. A little trickier when you have V carving, but it will give you that dimension. And there's a lot of times where that comes in really handy.
Yeah, I use that a lot.
Area. Yeah, that's great. Thank you. In fact, there's lots of information that you'll find down there. In fact, in this one, notice that when I select this text, notice what it says in the lower right. It says dish vectors. That tells me what layer that's on. So that's the other thing that's handy about that lower right corner, is it'll even tell you what layer the part is on. Now, if I select multiples, all it does, it says ×3 at the very end down here, because I've selected 3 vectors. But if I select a single vector, it'll actually tell me what layer it's on.
What's that circle right by the turkey leg?
That was a test circle. Don't need it. Okay, so anybody else?
Just from a
Yep.
design standpoint, I normally put a little shallow dish in the back of the dish, so
Yeah,
that you don't have just a flat surface, you've got a rim around it.
Yes.
I just think it looks nicer.
I agree. Yeah. So to do something like that, we could take that vector, which is, now that's this vector right here. Let's go to the chamfer. So we need a vector that's inside of that one. So let's take this vector, copy that, and let's shrink that down. Let's shrink it down by a 1/2 inch all the way around, see how that looks. Well, let's just even that out there. Okay, not quite enough, so let's go another 1/2 inch. Let's go 8.5, 4.5, and maybe even a little bit more. There we go. So you could use that vector to create a little hollow in the bottom using the pocket. Let's remove that. Go in and, well, let's see. I'm just going to grab my 1/4 inch end mill for now.
Yeah, I normally use a ball nose.
Oh, that's
just so
actually
that-
great. Oh, I like that. Let's do that. Let's use the ball nose too, because that has the advantage of leaving a nice little rounded edge.
Right.
How
And then
about a bowl cutting bit?
that would work as well.
Yeah.
Yeah, it's an excellent option. So let's go fairly. How deep do you typically go? Well, like in terms of
16th. I
16.
know I go about 60,000.
There we go. And then let's double check our step over here, because at 20%, now the ball nose, what kind of step over are you using?
60%.
On a Baldos, you're using
on ball nose.
really
Wow.
No, I know, you're right. Wait a minute. It's,
probably 6%.
6%.
Yeah.
Yes, sorry. One too many zeros there.
Well, you know what? I'm going to leave 20% in here because it's kind of fun to see what happens. We'll go back and correct it, but Baldos and V-bits, especially Baldos, it really, let's reset this here. Reset. Preview visible. So that's a pocket with the Baldos. But there, that gives a nice, but notice the texture, and that texture there is because of the step over. If you want to get rid of that with the Baldos, just like 3D carving, you need to have a step over somewhere, 6-7%. Some people say 7 to 8%. It just depends on your Baldos and what kind of results you're getting. But at 6%, that texture, you can see how tight that toolpath is now. It's going to leave a nice smooth edge. And what's really nice about the Baldos, it does leave that little inside round, and it does leave the bottom. It makes it very attractive. So that's a great tip. Thanks. Anybody else?
Yeah, Randy, why didn't you use the chamfer toolpath on the top chamfer?
I could have, but the V-carve toolpath gave me the opportunity, because the clearance part clears out the whole inside. So it's one setup that way. It just kind of makes it a little more efficient. You could use a chamfer toolpath, but then you'd still have to set up a separate pocketing toolpath to clear out the bottom. And the V-carve toolpath does both of them in one setup.
Would the V-carve work for both sides?
The V-carve could be made to work on the back side, but then you would have to set up a secondary vector, and you could set up, but then you'd have to determine where this bottom edge is right here.
Hmm.
And I don't have to calculate that when I'm using the chamfer toolpath. I just know that this critical edge is chamfer, this inside of the lip. That's my critical location. And so that's where the chamfer toolpath is handy on the bottom, because it calculates the distance going in, and I don't have to think about that. Again, it's very true that in this case, there are 2 or 3 ways that this could be done. And so those are not necessarily wrong. I just find it a little more efficient generally doing it the way that I did it. Anybody else? Well, just so that we're about wrapped up here today, just so everybody knows that everything I do is perfect, and that I make no mistakes, I have to show you how perfect and mistake proof I am. How's that? So not only did the very final cut, not only did I jam up my cut through the bottom, I actually broke the bit. I picked the wrong side of the vector to cut on, and before I was doing some testing, and I had the wrong bit. I had too deep a cut, and yeah, man, it went on and just went to town on it. So that was the first one. So that was a nice, pretty piece of cherry that I had set up, or maple, or whatever it was. And so I grabbed another piece of maple. It wasn't quite as wide as the first one, and I just stuck it on my jig, but I forgot to recenter it. So I ended up with a one-sided bowl on that one. And I said, okay, the third one's the sweet one, right? The third one always works perfect. So I grabbed this gorgeous piece of cherry, threw it on the machine, and got to the bottom and discovered a knot hole. I couldn't believe it. I hadn't turned over the wood to look at the other side of the wood because the top piece of the wood was so beautiful. So I know that doesn't happen to anybody else, but I thought I'd just show you that sometimes it takes a few tries to get it right.
It's nice to know our instructor is infallible.
It happens. So, any final words from anybody else?
Yeah, on that back side, I would have cut it out with the straight bit first. I don't like to bury a V bit. I know you do it successfully. It just makes me nervous to do that. So I would have run the lip cut first and then run the V bit cut, so I'd only be cutting on one side of it. Just me.
So that's actually a good suggestion too, and I've done that as well. So what Keith is referring to here is running this cutout first and even the lip. So then when you go back to do your V-bit, that material is already wasted away. And I actually like that, and I generally do that because, well, first of all, it just puts less burden on the V-bit. I like it. Yeah. The reason I didn't do it for this one, when I do these projects of the month, I try to be kind of as standard as practical, kind of logical. And it sometimes throws people a curveball to have to explain that. But in this case, if you were to say cut the registration holes in the table, you could actually leave the 1/4" bit in there, mount your board, cut the lip, cut the outside, and then put the V bit in. So you actually eliminate one tool change, which is another advantage. I'm always looking at eliminating tool changes, but it can get a little confusing to people that aren't familiar with that setup. But yeah, that's another great way of doing it. Thanks. Anybody else? All right, then. Well, then we'll wrap it up for tonight. And I'll see you guys next week. And we'll take a look at starting the Christmas ornament project.
2
Good
weeks.
evening. Good week.
2 weeks.
2
Randy.
weeks. You're right. 2 weeks in 2 weeks.
2 weeks.
Don't confuse us here.
I'm the one that's confused, right?
Yeah. Have a great evening.
You too. And everybody have a great Thanksgiving.
You
Thanks,
too.
Randy.
You're not going to do one of these on Thanksgiving night?
Yeah, exactly. No, I am not. Good night, everybody.
Good night, Randy.
Good night.